now we come to measures of centrality, okay? How to estimate the center of a distribution, okay? So let me explain something here. So when we have an attribute, okay, so now we have a number of samples, okay? So for that attribute, there are like, we have number of records, and for every record, there is a value for that specific attribute. Okay, but actually, what we have are just some samples. We don't know the exact underlying distribution for that random variable, that attribute, okay? So we don't know the exact distribution, but we have a number of samples. From those samples, we can estimate the distribution, okay? Yes, okay, let me read through these lines and then we discuss these things together. Often one number can tell a lot about the distribution, as we saw here for the normal distribution, okay? The mean and the standard deviation define the distribution. If we know them, then we know the distribution, okay? Because what we are plotting here is x versus probability of x. This is the distribution. This is the probability distribution of this random variable. So mu is what? Mu is the expected value. Okay, I wrote this here. So mu is the expected value, which can be computed this way, right? It's the integration from minus infinity to infinity, x times probability of x d of x. So if we know the probability distribution, then we know the expected value, which is the actual mean. Okay, that's for continuous random variable. For a discrete random variable, we take some x p of x. Okay, so this is the actual mean. Okay, if we know the probability distribution, then we can compute it. But in reality, we may not know the exact probability distribution, but we have a number of samples. From those samples, we can compute, for example, here for the mean. I will come back to this. From those samples, we can compute the sample mean, okay, which is the average, as we can see here. This sample mean, okay, is unbiased estimate of the actual mean. What we mean by this? So if I sample again and again, and every time I sample, I take a number of records, okay, and I compute the sample average or the sample mean, as the number of times I take samples goes to infinity, the expected value, okay, the expected value of the average converges to the actual mean, okay? Because I average again and again. Now the average is a random variable. The expected value of that as the number of as the number of times I sample goes to infinity, the expected value of the average converges to the expected value of the random variable x, or the actual mean. Also, as the number of samples goes to infinity here, this average converges to the sample average, or the sample mean converges to the actual mean, or the expected value of the random variable x. Okay, so the mean is one way to measure the centrality, okay, or the central tendency for both continuous as well as discrete random variables, but it's not the only way, okay? So the mean is one way to measure the centrality, but there is also the median and the mode, okay? In median, we sort the data, okay, according to the values of the different samples in ascending order, and we take the value for the one in the middle, that's the median. And the mode is the most occurring one, which is a good centrality measure for categorical attributes. Okay, we have one problem with the mean. The mean is very sensitive to outliers. In order to understand that, I actually plot this, I created this example here. Assume we have this data here. Most of the samples, all of the samples except one sample, are in this range between 0 and 5. And there is only one sample, one outlier, that has a value of 10 to the power 4. Okay, if I compute now the mean of these samples, it will be somewhere here, right? It will be here. Why is that? Because of this outlier point. If this point wasn't there, then the center or the mean will be here, which seems to be a more representative of the actual mean. So one outlier has significantly shifted the mean. Okay, so and this outlier could actually be a typo or a wrong entry. Okay, so that significantly shifted the mean to like very far away from the actual mean that or the one that can really represent this data. So yeah, so the as I said, the mean is very sensitive to outliers, but the median is actually less sensitive to outliers. Okay, as I said, in median, what we do, we sort the data here. I uh, included this example here. We sort the data, okay, the samples according to their values. So moving from the first element to the second element is not like it's controlled by the order, okay? It's not by the exact value, okay? So it's not like, it doesn't matter here. This is 10 to the power 4 or 6, okay? It's just one step, okay? So it doesn't matter. The value is not affecting the choice of the median. It's the order, okay? So with that, the median will be somewhere here, okay, which is more representative of the center of the data. Okay, if the number of samples here is even, if the number of samples, if the number of samples is odd, then the median we take after we sort them in order, we take the one in the middle. The value of that one is the median. Okay. If the number of samples is even, then we take the two in the middle, these two in the middle, and we average them. We average their values. Okay, that would be the median. Okay, as I said, and the mode is just the most occurring one. Okay, so if you plot a histogram, the category with the highest bar is the mode of the data. Okay, here we come to, okay, we have this example. We have this attribute or random variable. Okay, and for that one we compute the mean. Okay, we compute the mean, just take the sum and divide by the number of samples. There are 25 samples, we get the mean. And for the median, we sort them in ascending order. And since the number of samples is odd, then we take the one in the middle, 82. That's the median. And for the mode, as you can see here, there are two modes, 81 and 87. They are the most occurring ones. Their frequencies are the highest. And they have each one of them has occurred 3 times. Okay. So here how we do it with Python. So we're defining this list, okay, that has all the elements here, and then we create an NumPy array from that list. So by calling the function np array, and we pass that list. So we created this array. Okay, we imported from SciPy. SciPy is a scientific, it's a scientific Python library. So from SciPy, we import status. We will use it to compute the mode. So here, now what we're doing here, so we're calling the function mean, okay, inside the object. Okay, this is a NumPy object, okay. So we call the mean function in order to retrieve the mean, the median function, okay, and we pass here. This is the inside the object. And here we're calling np.median, and we're passing score as an input to compute the median. And here we use status module, which is a module that is inside this library SciPy. We we call that function mode inside this module, and we pass a score as an input in order to retrieve the mode. As you can see here, we pass an index 0 to retrieve the value, because, okay, let me first run it without indexing, okay? Okay, so here, if we run this is what we get. This is the mean, okay? This is the median. And as you can see here, the mode, what is it? So we have two arrays, okay? We have two arrays. The first array has one element, which is the first mode. Now for this data, we have two modes, but this function stats.mode retrieves only the first mode. Okay, so this is an array, contains one element, which is the first mode. And here, another array, okay, contains the number of occurrences for that mode. It has occurred 3 times, and it's an array as well. So if we just want to access the value of the mode, okay, we just index it by 0, we get the value. It's still an array that has only one element, okay? So if I want to retrieve the two modes, or assume a data that has more than more than one mode. In general, we call this function here multi-mode, okay? And we pass a score. So we need to import it from statistics. We import multi-mode. This will retrieve all the modes we have, okay? If there's more than one mode, it will retrieve all of them. So mode will retrieve only the first mode, okay? And multi-mode will retrieve all the modes. Okay, I think with that, we come to the end of this lecture. Yeah, let's stop here for today. Thanks for watching.